Hello guys, my name is Basem Aboul Hosn. Welcome to the Junior Breakthrough Challenge. Today I'm going to be talking about the Euler's formula, and I'm going to basically prove why e to the power of pi I is equal to -1. Thank you.
Hello, welcome to Euler's formula. I have a question for you. How many of you guys know what E is? Or at least how is it defined? To answer this question, we first need to learn how to think of numbers as actions. When we were young, we've always thought of numbers as counting things. Addition and multiplication are thought as respect to counting things. However, counting becomes tricky when we talk about fractional amount, and even more tricky when we talk about irrational, and it won't even make sense when we introduce numbers like square root -1. Instead, think of each number as three things: a point on an infinite extending line. An action that slides the line is known as an adder, and an action that stretches the line is known as a multiplier. When you think of a number that is an adder, you could imagine it as adding all numbers as points to the line all at once. But forget what you know about addition, so we can change the way you think about it. Think of adders as sliding the line with a rule, which is the point that corresponds to 0 ends up corresponding to the adder itself. Whether you apply 1, 2, 3, or more adders, the effect will be the same, and this is basically how we define the sum. Likewise, forget what you know on multiplication and follow the step. Basically what you need is to fix 0 in its place. Since multiplication is stretch, you would need to bring the point corresponding to 1 to where the point corresponding with the multiplier itself started off. Now, we can redefine multiplier as the successive application of two different actions. The life ambition of e to the power of x is to transform adders to multipliers and to do it as naturally as possible. For instance, if you take two adders and apply them, then plug it to a function, you'll get the same answer as pumping each adder through the function separately and then multiplying the two integers together. This shows that e to the power of x plus y is equal to e to the power of x times e to the power of y. You should think of this property as defining e to the power of x, and the fact that the special case of counting numbers has anything to do with the repeated multiplication is a consequence of the property. Multiply functions satisfy the property, but when you try to define one explicitly, one stands out as being the most natural, and we express it with this infinite sum. Did you know that the number e is just defined to the value of this function at 1? The function is much more special than the number itself. The convention to write this function as e to the power of x is a vested of its relationship with repeated multiplication. The other less satisfying natural function are the exponentials with different bases. Now the expression e to the pi I at least seems to have some meaning, but you should think about the infinite sum when trying to make sense of it. All you need to know is how to turn adders to multipliers. You could also check the sliding and the stretching in a 2D plane. This is what complex numbers are. Each number is simultaneously a point on the plane. An adder slides the plane so that the plane for 0 lands on the point for the number, and the multiplier which fixes 0 and brings the point for 1 to the point of the number while keeping everything evenly spaced. This now includes rotating along with stretching and shrinking, all actions of real numbers applied like sliders and stretchers. But now we have more complex actions. For instance, if you take this point and call it I. As an adder, it slides the plane up, and as a multiplier, it turns a quarter of the way around. Since multiplying it by itself gives -1, which means when you apply this action twice, it's the same as the action of -1. As a multiplier, it is the square root of -1. Adding is basically sliding left, right, up, or down. Meanwhile, multiplying is stretching and rotating. Since we know e to the power of x slides side to side into stretches, the most natural thing expected is to turn this new dimension of adders that sliders up and down direct to the new dimension of multipliers that rotates in terms of points on the plane. This would mean that e to the power of x takes points on this vertical line, which corresponds to adders that slide the plane up and down, and puts that on the circle with the radius equal to 1. That corresponds with the multipliers that rotate the plane. Most natural way to do this is to wrap the line around the circle without stretching or squishing it. This means it takes 2 pi to go around the circle. So if there's a natural way to do things, this is how e to the power of x will do it. In this case, there's no exception. There you have it. The function e to the power of x takes the adders pi I to the multiplier -1.